this is Lori and welcome to my series on the Pico W. This is part 8 of the Exploring LED Displays series of episodes. We're finally getting to our last basic LED display, the 8x8 LED matrix. The 8x8 LED matrix is kind of just what it sounds like. It's 8 rows by 8 columns, so a total of 64 LEDs that we can control. You can see I have a pinout of the 8x8 LED matrix over here. We have 16 pins to control this matrix, and unfortunately they're not labeled in any kind of order that would make sense to you. The rows and column pins are all mixed up, so you can see I have them color coded here. It is a bit of a challenge, as it has been with all these LED displays, to get them hooked up. There's just so many connections to make, and then when they're not in any kind of particular order, it's very difficult to make sure you got the right pin with where you want it to go. So it will take some time to get it wired up. As I said, I have a common anode, I should say, and the way to know which set of pins is which is the label on the side of this, at least for these models that I've seen. That label will be printed on the side where 1 through 8 pins are. So that's how you know which ones are 1 through 8 versus 9 through 16. And again, they're all jumbled up. Now I happen to have the common anode, so this is my circuit diagram. So the LEDs share the anode of the row, and then they all connect into the cathode, which is the column. And so to activate LEDs, you would activate the row and the column, and then that would turn on the LED at that intersection. Alright, so we want to turn on some of these LEDs. So I think the simplest thing to do first is just try to turn on a single LED at a time and be able to select the one that we want. To do that, we'll have to connect up the correct row pin to the correct column pin. And since the rows are the anode of the LEDs, I'll need to connect the row pin into power, and then to light the LED that I want, I'll also need to get the correct column connected to ground through a current limiting resistor. Got some little bit of traffic here on the road. I'm camping here up in Camp Failer. Looks like some construction going on, and yeah, so it's a little warm today, but it's really nice. It's beautiful here in the woods at Camp Failer. I love it. I actually kind of like recording up here. It's fun. Anyways, back to the LED matrix. Let's say we want to light this LED here in row 5, column 8. We'll get pin 16 and pin 1. Those would be the correct pins to connect up to get that one. And as you can see, that's how it's shown here on the diagram. So let's try that. Alright, let's do a little demo. I have one of the setups I've been doing for these LED displays. I've got the 8x8 matrix here on the breadboard. This side is pins 1 through 8, and this side is pins 9 through 16. And you can see got some power with the breadboard power module, and I have this blue wire connected to ground through the current limiting resistor up here to pin 16, which was column number 8. That controls column 8. And I have another jumper wire here plugged into the power rail, and so if I connect that into pin 1 here, I should light up the row 5, column 8 LED. And I do. And now if I pick another row, this is row 7, I should light that LED instead. And so you could jump around all the columns and rows and check all the LEDs if you want. I just thought this was nice to stop and think that this is really, in a sense, pretty simple when you use it this way, because it's just like having a regular LED on your breadboard. You're connecting it to ground through your current limiting resistor. Then the other side, your anode side of your LED, you're connecting into power to light your LED. Alright, so it's pretty easy to turn on a single LED, but typically we'd want to display a whole graphic, maybe a nice icon like the arrow I have on the screen here, or maybe some letters so we could display a message perhaps, maybe some data. So we want to be able to have the whole LEDs available to us to create whatever graphic or character we want to display. You might imagine, okay, let's tackle this arrow. So to get started with it, we would want to activate row 2, connect that to power, and then or send a high signal if we're connecting it up to our Pico. And then we'll need to ground or send low signals to columns 4 through 7. So that would turn on the LEDs that we want to start to form our arrow. Okay, so that worked pretty well. So then step 2, we say, okay, well, let's just work our way down the graphic, and then let's activate row 3, and we need columns 7 and 6 activated. They're already activated to do the first row. But now we're going to run into a problem because these columns are still active, so it's not going to work. We're going to end up with this block turned on, and that's not what we wanted. We need these two to be off on the next row. So the only way we're going to be able to make that happen is to loop through the rows and use persistence of vision. So we'll do each row at a time very quickly, and then we'll move to the next row, and that way we won't have any extra columns turned on for the next row, and we can work our way down the graphic very quickly, and it'll look like it's on because we'll do it fast enough that we'll use persistence of vision to make that happen. Alright, this is our circuit for this episode. We'll have our Pico here with our 8x8 LED matrix. The nice small one, the 20 millimeter square one, I think is a really nice one for doing breadboard projects. And it gives you enough room on both sides to make some connections. And you can see the blue lines are all the column pins, and I have them going through current limiting resistors into the Pico. And then the green lines are all the row pins, and they're also connected into the Pico. It's a lot of wiring, and I've had to, as before, I've had to wire and rewire this circuit many times. I've made my own jumpers in most cases to make it work, and it's easy to have it disconnect. So again, don't lose hope. It's worth it once you get it up and running and get it programmed. Our first program, we're going to do something pretty simple. We're going to try to light each of the LEDs one by one, starting at the top row, first column, work our way across the row, and then move to the next row and the next, going through all 64 LEDs, turning them on. So that's the goal of this program. We're going to import the needed libraries and set up the pins for the rows and the columns, and I've been very explicit here. There are certainly more efficient ways to write this code, but I wanted to be very explicit. Then I'm going to set up some lists for the rows and a list for the columns, because we'll want to loop over those. And in fact, the very first thing I do is loop over the columns and loop over the rows to basically kind of deactivate or turn them off. And then we'll get into the program. So in our while true loop, we'll loop through the rows. So we'll select a row and turn it on. Then we'll now loop through the columns within that row. We'll turn on a column by sending a low signal, hold it for a short period of time, then turn off that column, come around and catch the next column, and so forth. Then once we get done with that row, we'll turn that row off and come around and get the next row. So that should do what we want, and our keyboard interrupt will just let us turn everything off. So fingers crossed that everything's still connected. When I jiggle this thing a little bit too much, it doesn't work. So it's a little dark here. That's hard to see the setup. You can see the jumble of wires I have in here. And you'll also notice I have a network resistor instead of the individual resistors. So I'm using a 470 ohm network resistor right there to help with the wiring mess that we have hooking up one of these 8x8. matrices. So that seems to be working, and all the LEDs are coming on. So first program done. All right, little warm here. I can definitely feel a little warmth in my in my cheeks. Hoping it's going to cool off. I'm expecting some rain. Cool everything off here in the mountains. It shouldn't be this warm this time of year. But anyways, let's move forward. So we're going to try to show our arrow graphic in our second program. So we'll have all the same setup that we had before, but now we're going to be using persistence of vision. So we'll need those two timings that we usually use for persistence of vision. The persistence of vision time, how quickly we're going to move through the segments or the elements. So in this case, how quickly we're going to move through the rows. And so we'll do that in microseconds. And then how long do we want our graphic to be on the screen? That'll be in milliseconds, so I'm going to put it on for 10 seconds. Then I'm going to code up what the graphic is going to look like. So I want that arrow. So you can see I chose to use a list of lists. I do not think this is the most efficient. It's probably better to use bit arrays or something like that. But again, this is for experimentation, so I just used a list of lists to describe where I want the LED on and where I want the LED off. So you can see, because I have the anode, common anode, a 1 indicates that that LED will be off, and a 0 will indicate that that LED should be on. So here's our program that will use the persistence of vision. So we'll start our clock ticking, and then while we have not exceeded our display time, we're going to loop through the rows. And I want to just credit Keith Lohmeyer. He's a good colleague who often views my YouTube videos and gives me some nice hints. And he's in one of my previous episodes, you may have remembered I had a blank line to avoid carryover, and he gave me a hint that there was a better way to do that, and there is. And so I'm first going to set the columns I need on, and then I'm going to turn on the row, hold the persistence of vision time, and then turn off the row. So in this loop, we're going through finding the correct row and column, looping through those columns, turning or activating, I guess is like the word I like to use, the columns we need, and then turning on the row, and so forth. So this little loop should hopefully make our arrow appear. All right, let's give this a try, and we'll run it. To my eye, it's looking good. I was having some trouble filming it. I don't know whether it's the lighting here, but hopefully it'll show through on the recording. Okay, just a small step. Let's try to show a message on our display, and the message I'm going to show is Lori's Robots. And I'm going to do it a real simple way first, and then we'll do it a more satisfying way in the last program for this episode. So our setup is as it has been before, and now I took the program from, sorry for all the scrolling there, I took the program from our last demo, and I turned it into a function. So you can give it the graphic, your persistence of vision timing, and your display time, and it's going to put that graphic on the screen for you. So that's nice to have as a function now. And then to put Lori's Robots on, I've got to have graphics for each of the letters, and I also need a blank space between Lori's and Robots. So I have all the letters coded in here, and I think I acknowledged, yeah, somewhere I acknowledged that, yeah, where did I acknowledge that? I just want to point out I took the design of the letters from this GitHub site, so I appreciate someone sharing that. I'm not very good at that sort of thing. So I did mixed case, so I have an upper L and a lower O, R, I, a quote, and an S, and so forth. So these are all the letters I'm going to need. Now, I didn't put the whole alphabet in. You certainly could do that, but I do think there's probably more efficient ways to do it. And then I made a list of those graphics so that we could loop through them. Now to do that, I'm just going to loop through the characters in the message, put them on the screen for a very short period of time, and then sleep to pause before we show it again. So hopefully this will go. Yeah, okay, so that seems to work. But it's a little hard. If you know what I'm going to put up, then you can see it. But if you're not familiar with what the message is, it might be difficult to get the message doing it this way. And I'm sure many of you know the way to do that would be to scroll the letters across so it's easier to see the message. So let's take that challenge of figuring out how to scroll through the letters rather than just showing them one by one as we have here. Well, to scroll through the letters, we're going to need to sort of move through the letters and create graphics that are going to combine letters as we move along. So let me kind of, I put the first three letters of our message up here, and so the first one we'll show is the L, and that's easy. We have a function that would show the L, but now we want to, in the next graphic we want to show the last 7 columns of the L and the first column of the O. It's kind of like a moving window, and we want to move across, and this is the graphic that I want to show very quickly, so it looks like Lori's Robots is moving across the display all the way along. So we need to create a function that's going to kind of combine these characters that we have defined, at least the way I've defined them, and combine the right pieces and move it slowly, or not slowly, quickly across the letters. So first thing you may notice is this window never encompasses more than 2 of the characters that we have defined already. So our function that'll make this sort of moving window to get the graphic that we want to show only needs to take care of 2 at a time, and then you can see here it'll get to just the R by itself. So that's the kind of function we need to make this happen, at least the way I have things stored up in the program. The final program for this episode, where we'll scroll our message across the LED display. We'll have all this code that we've been putting together, our show graphic function, all the characters we need for our message, and we'll get to our new windowing function, where we're going to be able to combine the 2 characters, the one sort of in the front, character 1, and the one coming up, character 2. And we'll be able to shift across, so that shift parameter allows us to say how far do we need to shift. Do we need to shift just 1 column, 2 columns, 3 columns, 4 columns? So that's what the shift controls. And to do this, we'll just start off with a new character as a list. And we're going to work through the rows, so we'll build each row as we go. So we'll work on the first row, and what part of character 1's first row do we need, and then add that to the part of character 2's row that we need. And then we'll work through all 8 rows, appending each as we build it, and then finally returning the new character so we can show it on the screen. So that should work. It was easier to do than I thought, but it does take some thinking to get an idea about how you want to work with it. I'm sure there's a dozen different ways you could do that kind of window function. So now our program's pretty short. We're going to loop through the message. Then we will shift through the current characters that were in our message. We'll shift through them all the way until we're fully to the next character being displayed, and then we'll come around and grab the next character, and they'll switch places, and we'll shift through those. And we're going to move pretty rapidly through this, and then we'll have a little sleep in here just so we can signal that the message is starting over again. So hopefully this will work. There we go. All right, Lori's Robots. Yeah, very satisfying, and it was really nice to get a sense of what it takes to scroll these kinds of characters across a screen like that. And it certainly makes me appreciate the library authors that have put this together for the displays that have these driver chips. They've done a lot of nice work for us, and a lot of programming involved in getting that to work. Although I'm sure they did it in much more efficient ways than I did. But it was fun to give it a try. So the next episode we'll use the 8x8 LED matrix again, and we're going to try using 2 shift registers to control the rows and the columns, and that way we won't have to use as many of the pins on our Pico to operate our LED matrix. As always, thank you for watching.